Okay, welcome to Chapter 8, Lesson 10, Inverse Variation. Now you remember that we've done direct variation, and that looks like this. Y varies directly as x. Y equals k times x. So we want to take the idea of the relationship between two sets, and we're going to change it not from direct variation, but now to inverse variation. Inverse variation is something like this. Suppose I need to go 100 miles. If my speed is 10 miles an hour, then how long will it take me to get there? 10 hours. If my speed is 20 miles an hour, what will my time be? 5 hours. And 25, 4, 52. So what we're seeing here is when the speed goes up, the time goes down. This is a relationship of inverse variation. Notice that 10 times 10 is 100. 20 times 5 is 100. 25 times 4 is 100. 50 times 2 is 100. They always multiply to be the same thing. What we're going to say is that y varies inversely as x. And when you see something that says y varies inversely as x, you're going to write it like this. Y varies inversely as x. Y equals k over x. Y equals k times x. Okay, so the idea is that we have direct variation and indirect variation. Okay, so let's work one of these problems. Now, in the same way that you could get a proportion out of this thing, like y divided by x equals k, and you can make a proportion. You can do something similar here and do x times y equals k. When you multiply these, it'll always be the same. So x times y is k. Now, if I take x times y equals k, it will be not a straight line. Instead, it'll be something like this. I'm just going to show you the picture of it. This graph is called a hyperbola. And notice it'll never touch any of the axes. That's because x and y will never be 0 when this is a constant. K is never going to be a 0. So that means x and y will never be a 0. Okay? So you'll see that this kind of graph is what x times y equals k produces. Okay, let's do a problem. Okay, suppose you've got a little balance beam. The shadow's kind of bad today. Suppose you got a balance beam. Here's the fulcrum. This thing's balanced in the middle. You got something hanging right here and something hanging right here. Okay, now if this thing weighs 24 grams and it is 30 centimeters away, and this one weighs 45 grams, it's heavier, how far away does this one have to be? Well, we can use our indirect variation, because what we're going to say is that the distance, hold on, we'll say that the distance varies directly or inversely as the mass. Or in other words, that the mass of this one times the distance of this one is equal to the mass of that one times the distance of that one. So we know everything but this, so we'll plug in our numbers and find out how far it should be. So 24 times 30 is equal to 45 times the unknown distance. So divide by 45. Now simplify here. Oh, excuse me. There we go. So the answer is 16 centimeters. Done. All right, you guys start working those problems and let me know if you have any questions.